Hello and welcome to CoT Over Time. My name is Kev, and in this video I'm going to walk you through the architecture of Varcade Games. So if you don't know what Varcade Games is, please go check out one of my other videos. I'll link them somewhere here and you can get a sense of what the project is. I've also got videos that will help you set up the project and get it running on your local environment. And I've got some videos that kind of walk through reverse engineering the website and getting a little bit into the code. So all of that is really useful context, and once you've done all that, I think the discussion about the architecture of the overall thing will be much more straightforward. So yeah, let's get into it. Once we've gone through the architecture, I am going to give you a kind of a coding challenge that you can take away, and in the next video I'll go through a solution to that coding challenge. Basically, we've got a small kind of bug or annoying thing in the website that we're going to try and fix, but let's not worry about that for now and jump straight into the architecture. So this image here basically describes the whole Varcade game system, and it is available on the CoT Over Time Varcade Games GitHub page. You just need to come to the wiki section and scroll down on the right hand side, system architecture, and you'll find this diagram right here. So there's a lot going on here, and if you've never worked with a reasonably sized system before, this will probably be all pretty overwhelming, but we'll go through it step by step and it'll be fine. If you've been playing around with your Varcade game setup, if you've tried to play a multiplayer game and you've generated, a leaderboard and some stats and stuff like that, well then you will have experienced more or less every part of this system. So we will naturally start over here at the Varcade Games client. So this is essentially this, right? Everything we've kind of been interacting with so far. It also includes, if I go back to the home page, this page here, the sign in, the actual list of games, and this page here, but not the game itself, right? So the game is actually injected into the client, but everything else kind of surrounding it, that is the Varcade Games client. So that should be fairly clear and fairly intuitive. And actually, when you load up this page here, you're more or less just interacting with the Varcade Games client. That's all. There are a couple of requests to the server to get some images and stuff like that, but really you are only looking at the client at that point. Now, when you actually hit continue as guest, or if you actually go and sign in and you load up this page, as we saw from the reverse engineering video, what's happening is a request is being sent to the Varcade Games server. So when you load this page, when you load the client and you load the page with all the games, a request will go to the server and the client is saying to the server, hey, give me all your games. The server will then return a list of all of the actual games, and then the client will say to the server, okay, give me the images for all of these different games. So there's a bit of a back and forth that happens to populate this whole page here, and the actual Varcade Game server you have interacted with directly before yourself if you have set up this project, because in the admin page, this is the Varcade Games server. This is the actual server that the client is talking to fetch all of the list of games and all of the images and stuff like that. So this is the server right here. We can see our users. Here's me. You can see some accounts I created in previous videos. And you can see all of the games that I have added to the web portal here. So this is basically controls all of the games that you actually see on the website when you log in, the user accounts, all of that sort of stuff. All of that has been managed by the game server. And further than that, you'll see this is connected to a MySQL database server. So this is an SQL database. MySQL is a kind of popular open source SQL database. And when you set up the project yourself, which you've hopefully done, you will have initialized this database. So there was a step during the setup where you had to connect to the game portal Docker container. You had to run a script, which was manage.py migrate, and then you had to run another script, which was create super user, and that's where you initialize your database and you added a admin user to the database. So all of that was just setting up this guy here. So all of this is pretty straightforward. This is kind of your typical client-server relationship that you'll usually have. You have a client, it talks to a server, and the server will usually talk to a database, do some stuff with the data it gets back in the database and send it to the client. The client will send requests to the server will do something with the request, fetch some data, and that's typically how that kind of cycle goes. So that's the kind of most basic view of Varcade Games, and if you've ever done any sort of client-server development, even a very basic project, you will likely have seen this sort of a setup before. Now, where things get a little bit more complicated is when we have our games, and we have basically fetched all of our games here, and I click info on this game and I press play. Well, what happens is we're in the game client still, but now we actually have a game, and this game is our RPS client, right? Our rock, paper, scissors client. And in fact, any other game that we build, so I've mentioned before, all of these other games are like dummy games. Battle Grannies doesn't actually exist. I wish it did, but it's a dummy game. But our rock, paper, scissors game does exist. And what happens is our game, Varcade Games client, opens up this page, which is just an empty blank page. You know, in the future we'll do something with this and make it more interesting. But for now it's just a blank page, and what it does is it fetches the rock, paper, scissors client. So if you remember when we set up our game here, rock, paper, scissors, we had to put in this client URL. So when you load this page, what this page is doing is it's sending a request to this server to fetch some JavaScript, which is called main.js. And when this page does that, it will get the JavaScript back and it will embed that in the page and it will run the JavaScript, and that's how we actually get our game. So the game is embedded into the client. Now, this game is also a multiplayer game. So it has a game server. Now, if I go to our command line, I'm going to clear this out, and if I do our make PS, which you should have seen this before, now we can kind of see everything that's listed here. We can kind of see in this diagram. So here we've got game portal client, for example, which is our Varcade Games client here. We have our game portal, which is the server, which is here. And you'll notice game portal over here, you can see some familiar numbers. This 8,000. Remember our admin page was localhost 8000. If we look here again at our game RPS client, you'll see this is 8090. Okay, 0.0.0.0, 8090. It means that this container is basically listening on port 8090, and you can connect from any location or any IP, basically. Let's not worry about the details of that right now. But you can see here 8090. That is our client that we put in here. So we're starting to kind of build a picture of how all of this stuff is connected. Okay, now the game RPS here, this is the game server that we're talking about. So you have a multiplayer game. So our game client will connect to this container, which is listening on port 8080. We have our game portal DB, which is our MySQL database server. So that's here, and that's listening on 3306, which is the default port for MySQL. And you can see we have a matchmaker, we have a stats tracker, and both of those also have a worker, and we'll see stats tracker worker, a matchmaker worker, and we have a stats tracker server and a matchmaker server. We'll go into how they work now in a second. But you can kind of see how each of these containers kind of maps to one of these boxes on our architecture diagram. So our client is embedded, our game client is embedded here, and it connects to a game server. Now, we don't want users connecting directly to the game server because we want the game server to be worried about gaming, right? We want our game client and our game server. The idea of Varcade Games is that it's a portal and that you should be able to come along with any game and just plug in that game. And we don't want game developers worrying about things like matchmakers and leaderboards because, you know, that's not really part of the game. Those systems, they're not the gameplay, right? We all like a leaderboard and we all like stats about what we're doing in the game, but they're not the actual gameplay. And as a game developer, I want to do cool stuff with graphics and I want to create fun gameplay and I want to do fun game design things. So what we've done is we've tried to abstract that away. And the way we do that is we provide a matchmaker for these games to use. So as a game developer, you come along and say, oh, Varcade Games looks like a cool web portal. I'm going to put my game into Varcade Games. Oh, and they've got a matchmaker and they've got leaderboards and stuff. Cool. I'm going to connect my system to that system. All right, so how does that work? Well, the matchmaker server and the game client and the game server all, and the Varcade Games client and the game server all kind of need to be able to talk to each other. Okay, so what happens is, when we try to play a multiplayer game, okay, so here I'm actually not logged in, so I'll need to log in real quick. And I'll hit play. And I'm going to hit multiplayer. So when we hit multiplayer, we get this window popping up. And it allows us to create a game, or you can refresh the game list because there's not currently any active games. And if this UI here, by the way, this is nothing to do with the game RPS game. This UI here, the available games UI, this is part of the Varcade Games client. So when I create a game, essentially what happens is the Varcade Games client is going to talk to the matchmaker server and say, hey, I need you to create a game, and I need you to create a game for this user, right? And this is the other reason why we don't want the actual game server to be worrying about things like matchmaking. Is we don't necessarily want them to have to care about users and worry about users and all of that sort of stuff. We have our users stored over in our database over here, right? We want the game to just be agnostic. We want to be able to just take two people and put them together and play the game. That's what we want to do. We don't want to have the game server worrying about all that stuff. So the Varcade Games client has the user logged in, and we can send a request to the matchmaker and say, create a game. And the matchmaker will basically create a game, and it will send a message to the game server to say, hey, I've got a new game. You need to keep track of this game on your server, right? And then what the game server will do is, okay, I've created the game. So the game is now active. The game is live. People are ready to join. And it will go back to the matchmaker with a token. And that token will then be sent back to the client. So the user says, right, I have a token now. So with that token, the client can actually connect to that specific game. Okay. Now, I did say this would seem kind of complicated and seem like a roundabout way of doing it. But once we actually get into some development and working on these features, I think it'll become a bit clearer. But essentially what we're doing is, when you're joining a game, the matchmaker server gives you as a user a token. And then you use that token to actually connect to the game server. And that's kind of how we're doing our authentication. We don't want any user just to be able to connect to any game. Okay, like if I create a game by the matchmaker and I join the game, I'm going to be connected to the game server. I'm going to be sitting there waiting for other people to join. Now, when someone else comes along and they try to actually join the match, they'll also get a token for that match. So they'll only be able to join that one match that has been created via the matchmaker. And the matchmaker is kind of storing a list of every game that has been created. Because if you come along and create a game, like in your local server, if I select multiplayer and I hit create game, what has happened there behind the scenes is I've sent a request to the matchmaker server. The matchmaker server has created the game on the game server. The game server has returned my token, which is returned to me, the user. And now through the client, I have sent a token to the game server. So now that the client is connected to the game server. So here I'm actively connected to the game server. I have created a WebSocket connection. And I'm going to press fight. And what's happening here is I'm in the game and I'm waiting for an opponent. So an opponent in this case is not actually going to join, and that is a situation we need to account for. But basically it means there's a game now live on the RPS server. The matchmaker has one game now that is available to join, and if someone else comes along and opens the matchmaker UI, they'll see that game is available to join. And if they join it, they will also get the token that will allow them to connect to the same game as me. So that's how these things all kind of communicate and connect with each other. Now, the matchmaker server obviously needs to store all of the games that are active, because me as a user, if I want to fetch some games, they need to be fetched from somewhere. Like if the matchmaker server dies for some reason, we want it to be able to restart and still be serving out all of the active games. So when you create a game in the matchmaker server, it creates a game in our Redis database. Let's see. Okay, so here we've got a connection error where basically we got kicked out of the game because the game timed out. We've got some logic in the background where the matchmaker says, hey, nobody joined this game within 90 seconds. We're going to close the game. That's all configurable. We'll go into that in the future. But back to storing the games. we have this Redis database here. And if you don't know Redis, Redis is basically an in-memory data store. And it's a really, I'm biased because I really, really like Redis. But basically it allows you to store data very quickly, very easily. It's very, very fast. It's good for things like caching and data that is not necessarily critical data in terms of storage. Okay, like if we lost all the data in this database, it wouldn't be the end of the world. It's not the same as losing all your user accounts, right? You would lose all of the active games, but people can come back and they can create new games, and it's not necessarily that big a deal. But I would encourage you to go read up on Redis and maybe play around with it and get a sense of how Redis works. I will do another video on Redis where we'll go into much more detail. But basically our games are stored in Redis. So when you come in and you say multiplayer game and you do refresh games, it will go to Redis and say, hey, have you got any games? And then that list will be returned and that list will go back to the client. So that's kind of how our matchmaker is set up and how our matchmaker works. Now, there's another thing that Redis can do. It's called a stream, right? This is a feature of Redis called Redis Streams. Let's see, do they have anything on streams here? I'm not sure exactly where the docs on streams are, but basically what it means is we can send data through into a stream within Redis. So I can send events to Redis, and then there can be some process on the other side of Redis that's consuming those events. So why would we want to do that? Let's use a real world example here. In a previous video, I showed that when we play in multiplayer, you can go to this page and you'll see your stats. So you'll see how many times did you use rock, how many times did you use paper, how many matches did you win, how many matches did you lose. So basically our game server here, and any other game server that wants to be connected through Varcade Games, can connect to this event stream, okay? And it can send events, like it can say, this game completed, this user won, this is how many times they selected rock, this is how many times they selected paper, this is how many times they selected scissors. And these events all get fired through Redis. And we will also send events like this game has started, this game has ended. All the players have joined this game. So let's say for rock, paper, scissors, you can only have 2 people join a game. So what will happen is the game server will send an event saying 2 people have joined, okay? And then if you remember, I mentioned a worker before. We've got a matchmaker worker. And behind the scenes, we've got a container here called matchmaker worker that's just kind of sitting there listening to this event stream. And if it gets an event to say this game now has 2 players joined to it, it will go to Redis and say, okay, you need to take this game out of the available games to join. Because if 2 people have joined this game and you come in and you want to look at all the available games, we don't want the server giving back games that you can't even join because it's already full. So the matchmaker worker will keep track of the state of the game. Or likewise, if the game ends, it will be removed from the database. So the matchmaker worker is basically keeping an eye on the state of the game. But in order for it to keep an eye on the state of the game server needs to be sending events that are updating it on what is the actual current latest state of the game. Similar with the stats tracker, events are being fired like game was won, game was lost, rock was used, paper was used. All these events are being fired, and this worker is just basically connecting to this queue. If you just imagine like a queue of people, right, and you've got people being added, there are events, and at the top we've got someone saying, you know, you can leave the queue, you can leave the queue. And everybody in the queue has a message that they're going to pass to the person at the top of the queue that is now allowed to leave the queue. So that's essentially what's going on here. And all of this is, we're basically keeping track of the state of all of our active games through these workers. Now, our stats tracker is, it's keeping track of all the stuff for the leaderboard, and we store the leaderboard in Redis. We store all the player stats in Redis. Redis, incidentally, is really good for leaderboards. A lot of people use it for leaderboards because it has a data structure that makes it useful for that. But we won't go into that right now. The important thing is it stores all the data in there, and then we actually have a stats tracker server. Now, you'll notice that neither our Varcade Games client or RPS client actually connect to the stats tracker server. We don't want that server exposed to the world, so basically our Varcade Games server behind the scenes connects to the stats tracker. So the Varcade Games client will say, hey, for this game, give me the player stats and give me the leaderboard, and then the game server will then go connect to this other server and say, give me that data. So we've got some server-to-server communication going on here. And that is essentially everything. You can actually see all of this. I mentioned before we have this command make logs, and if we, for example, go to this command, when any of these commands where we have make logs, make build, make start, you can always do a equals. A in this case stands for app. So I'm saying get me the logs, app equals matchmaker worker, right? And that will get me the logs just for that specific container. And if I do that, we can actually see some events of what's going on behind the scenes of some of the stuff that I've just been talking about. So you can see here we've got some initialization going on. This is just the thing starting up. The worker here is processing a stream event. So we can see it's got an event with some information, EXRPS. What is that? Well, that should be familiar because if you remember, that is the game ID that we gave to rock, paper, scissors. So this event is related to this game, okay? It's got a game ID associated with it, and it's saying the type here is a state change and creator joined. So our matchmaker worker is processing an event, and that event is saying that the creator joined. So in this case, what's going on is someone has created a game via the matchmaker server, and then the person joined the game, and then an event got fired to tell the matchmaker worker, hey, a person joined this game. And only when the creator actually joined the game does the game become available for other people to join. So that's kind of one of the things that's going on in terms of message processing and passing here. So what else happens now? The state is creator joined, so the game's state has been updated. And then it says activating game, so the game is being activated now. And then if you remember, I said nobody joined. So we've got a log message here that says expiring game. So the matchmaker worker expired the game because it got a message to say the creator joined, but it never got a message to say another player joined, and too much time passed. So in this case, we can see basically the timeout is a minute, because we can see the creator joined here at 10:35:58, but the game expired at 10:36:58. That's a minute. In the real world, you'd have it a bit longer, but for the sake of our development, we don't need that to be too long. So then what it does is attempting to send a cleanup request to the game server. So here the matchmaker worker will say to the game server, hey, I'm cleaning up this game. So it sends a request to the game server to tell it to remove the game and disconnect the user. And there was a removal event for a non-existent game. So that is the matchmaker worker and the matchmaker worker's kind of view of what just happened by us creating a game, joining the multiplayer game, but then no one else joining. But what if we have a look at, say, the game RPS, which is our game server. So here we've got some stuff going on where we see our server is initialized in development mode. We received a create game request. So we can see, well, the user name that we gave the person is this is a bad name. If you remember from a previous video, that for some reason is the name I gave the account. The user ID is passed in, all that sort of stuff. So the game server received a request, and remember it's the matchmaker sent this to the game server. So it creates a new game for this user and creates a game ID. The socket connection is opened, right? The user has connected. So we're initializing and then successfully connected to the user to the game. And here now, remember the matchmaker worker was cleaning up the game because it expired. Here's the game server actually receiving that message. And then it's removed the game and the socket connection gets closed. So we can kind of dig into the logs and get a sense of how things are happening here. And what I would ask you to do at this point is play a multiplayer game. So if you log in here, press play, start a new multiplayer game, open a private tab, log in with a different account, play the multiplayer game, and then go have a look at the logs and see what's going on here, right? And have a look back at this diagram and see, can you put together the picture of everything, how everything is working. Now, in the future, we're still talking very high level here. In the future, I'll do videos where we'll actually do work and go into all the specifics of all of this stuff. But for now, I just kind of wanted to paste a high-level picture. I think I've been talking for about 25 minutes already, so I'm going to wrap it up there because, attention spans are what they are, and I don't want to exhaust your brain too much in one video. Hopefully that made sense. If you have any questions, please leave them in the comment section, or you can join the Discord and you can ask me there. If you're interested in this stuff and you want to kind of join in and you want to work on this project and build your software engineering muscles, please subscribe to the channel, hit the notification bell, all that stuff. I did say at the beginning I wanted to do leave a bit of a coding challenge or a bit of homework for you. As I've said in previous videos, it's really, really important that you are hands-on with this stuff, that you're actually doing it. So like I mentioned, jump in, have a look at those logs, do a multiplayer game and try and figure out how all these communications are going. Like what happens if you look at the logs for the stats tracker worker after you complete a multiplayer game? What's going on there? What are the events it's consuming? That will all be in the logs. All useful information for you to look at. But for our programming challenge, I said I've got something annoying that has been annoying me. I've got a fix for this, and in the next video, I will go through the actual solution. But watch this. If I click Rock, Paper, Scissors, Apocalypse here, now I have scrolled down the page and I'm clicking the one at the bottom, and I hit play, what happens? It loads up this page, but I'm scrolled down the bottom. That is really annoying. Every time I have to scroll back up. Now, if I go back here and hit play from the top, well, I'm already at the top, right? So what's happening is the scroll from this page is kind of being preserved into the next page. And I don't know about you, but that is wrecking my head. So today's challenge, today's homework is fix that, right? Jump into the code and actually fix it so that that doesn't happen anymore. I will give you a clue. I will walk you through a little bit of the code. So we have our game portal view, which is in website client source, views, game portal. And here you can see we have our list of active games, single player game, all of that stuff. And down the bottom we have WP game info. Now that WP game info, that is this thing, right? And that thing, if we open up this is in the components directory, WP game info.view, that is a modal, right? And again, documentation time, go read the documentation. This is a Vue.js. Basically we're using Bootstrap Vue, which is a kind of a CSS framework if you like. And this kind of talks through how modals work. So there are examples on this page, launch demo modal. You can see there, and there's all different types of modal. If I come down here, that modal is slightly different somehow, and it gives a whole bunch of different things, right? Different modals you can have. So that will explain what a modal is, but this is what that actual pop-up is. And that is launched by, you know, clicks and stuff that are happening on buttons, and when we click play, we will have this redirect to game method, and it's going to say router.push, and it will go to games play with the game ID, and that's how we then open up the gameplay screen. So I don't want to give too much away. Like I said, I'll walk through the solution in the next video. If you want a hint, stay tuned at the end and I'll give you a quick hint. But other than that, good luck. And like I said, any questions in the comment section. That is all for today. Thank you for watching and have a great rest of your day. Okay, here is the hint if you wanted to hang around for the hint. If you don't want the hint, exit the video now. If you do want the hint, basically we go to source main.js and we have this thing in main.js called the router, right? The view router. And this is the thing that if you remember, we actually launched, or we used it to change from page to page. So we have this function call here called redirect to game, and that's called router.push, and that's how we actually open up the new page. Well, this router in Vue, you can actually use the router to decide how the page is going to be displayed when you click into it in terms of the scrolling. So that should give you enough. View router, scroll, behavior. You can look that up. You can check out the documentation, and best of luck. Have a great day.